Of matrices here. And in talking about matrices, some of the vocabulary that you need to understand is how you talk about the dimensions. So the dimensions are this: number of rows by number of columns. It's rows by number of columns. And so when we look at the matrix in problem number 6, how would you describe its dimensions? 2 by 4. And for problem number 8, 3 by 1. Good. So 2 by 4 and 3 by 1. I always used to joke that I had a corporate sponsor for this part of the class, and it was RC Cola. It was a row then column. But it's a good little mnemonic. Good luck finding RC Cola. The last time I had somebody find it, it was a student at Michigan State who said, "Oh, there's a vending machine that has RC Cola," and actually brought me one. I forgot to bring it this morning, but I do have a can of RC Cola in my office. Actually, I should say a bottle. Anyways, so they're not giving me any money, so enough free advertising for you guys. Let's work with matrices and start building a connection between matrices and systems of equations. So that connection is in the form of what's called an augmented matrix. Augmented matrix. And it's just a nice, straightforward connection between a matrix and a system of equations. So it's in the form of problem number 12, negative x plus z equals negative 1. 3y minus 2z equals 7. And x minus y plus 3z equals 3. So the matrix that's associated with this is the matrix of coefficients. So that matrix of coefficients is going to have a dimension of 3 by 4. Now let's list the coefficients of the first equation. Kenny, what are the coefficients here, please? Negative 1, 0, and then negative 1 on the right-hand side. Cool. And we're going to do the same thing with the next one. So 0, 3, negative 2, and 7. And the last one as such. And there's your augmented matrix. Yay. Easy 2 points. So I'll try and put at least 30 of those on the exam, right?
Yeah. That was easy.
Yeah, cool. All right. So what's the point about it? Well, the point is to start bridging the gap between calculators and systems of equations. Let's do one kind of in the opposite direction. Problem number, let's see, let's do problem number 18. So in problem number 18, they give you a matrix, an augmented matrix, and they ask you to write the corresponding system of equations. So something like this. So we're doing the opposite of what we did in problem number 12. We're starting out with the augmented matrix and going to the system of equations. Now it's not really written, but it's kind of understood. Some authors will write it like this. They'll put a little slash through here, the dotted line, to help you remember that that's really the right-hand side of your system of equations. But what system of equations is represented here? X equals 1. Z equals 3. So that's cool. If we could somehow or another get our augmented matrix into that form, wow, that'd be easy. You could just read off your solution to that system of equations. So this form of an augmented matrix is about as nice as it gets. It's called reduced row echelon form. Reduced row echelon, ESCH that's right. Let's double check. ECH. Yeah, ECH. ELON. Reduced row echelon form. Basically where you have ones on the main diagonals and zeros off that main diagonal, except for the right hand side. So it's nice if you get in that form, but we can deal with lesser forms and still be okay. So let's take a look at a couple problems where we start manipulating these things. And we're going to do the same things here in these augmented matrices that we would if we're dealing with a system of equations like section 10.3. So let's take a look at problem number 22. In problem number 22, they give you this matrix, -5, 2, -3, and 3, 10, -3, 1, and -20, -1, 3, 1, and 8. And now, in thinking of this, just like our systems of equations from section 10.2, one way to solve these things would be to get zeros in a couple of these places. That is, to get rid of a variable. And what they tell you to do is take and add 2 times row 1 to row 2. And let's see what happens here. 2 times row 1 would be this number, or these numbers. -10, 4, -6, and 6. And let's add that to 10, -3, 1, and -20. So I get 0, 1, -5, and -14. That's my new second row. So, did I change the first row? No. I didn't change the first row. I didn't change the third row. I just changed the middle row. So it would be -5, 2, -3, and 3. And my new second row, 0, 1, -5, -14. And the last row hasn't changed. Well, see, the nice thing about this, well, there's two nice things. One is that you don't have to write all the variables. They're just kind of understood to be here. And the second thing is that numbers are things that your calculator can work with. And we will get there, working with our calculators on these things. Now, let's jump up to a problem like number 26. I mean, problem 24, which I'd like to do, is asking you to do the same kind of thing again. But I want you to understand why we would manipulate things like that. And we can see that with a problem like number 26. So 1, 1, -3, 8, 0, 1, -3, 5, and 0, 0, 1, -1. So this is an augmented matrix. Just a reminder, that little vertical bar, which the book doesn't write, separates the right-hand side from the left-hand side. Let's see if we can't figure out what kind of a system of equations this represents. What's represented here? Start with the bottom one. Z equals -1. Good. Someone else for the next one. John? All right. Y minus 3z equals 5. Good. And then the top one? Cool. Now, I claim that there's something special about the form of this system of equations. It's pretty easy to unsolve. This form of a matrix is just called row echelon form. It's not as reduced as our previous example, but it's good enough because take a look here. We know what z is, right? If I know what z is, then what can I solve for? I can solve for y. So I get y minus 3 times negative 1 equals 5. So that's a plus 3. Subtract from both sides. I get y equals 2. Great. Y equals 2. Substitute that back into here, along with z equals negative 1. And wow, x plus 2 minus 3 times negative 1 equals 8. So it's going to be x plus 5 equals 8. X equals 3. Hey, that's special. That worked out pretty nice, didn't it? If you have your matrix in reduced row echelon form, you can always kind of unzip these problems. This subs to here, both those into there. Done. Rue, did you have a question? Okay. So we're going to work towards getting things in reduced row echelon form. That's what we're going to, or excuse me, row echelon form. Yeah.
Row echelon is when you have the 3 zeros in the corner, right?
Yeah, reduced row echelon form would have zeros above and below here. That's more work than we need to do, but you could do that. You could finish this up by putting it in reduced row echelon form. So,
You don't need to.
no, I was actually debating showing you a cool trick on your calculator.
I know that you can do.
That I can do? Do you give me permission to do that?
If it helps on the test, yeah.
All right, I'll show you some tricks on your calculator. But tell you what, let me just finish this one up a different way, but by putting this matrix in reduced row echelon form. So what I could do then, once I've got it in this form, is I could add 3 times row 3 to row 2. So 3 times row 3 to row 2. And what would that do? That'd make this a 0, right? And 3 times that would make it a 2. So I'd end up with this equation. I'd end up with 1, 1, negative 3, 8, 0, 1, 0, 2, and 0, 0, 1, negative 1. So that's great. I can actually read off 2 of my numbers now. To finish this up, I'd multiply this by 3 and add it to this equation. So 3 times row 1, or row 3 added to row 1, will give me 1, 1, 0, 5. And there's one last thing I got to do to put this in reduced row echelon form. And that would be get rid of the 1 here.
Times row 2 by negative 1.
Yeah. So negative 2 times row 2 added to row 1. And I have 1, 0, 0, 3, 0, 1, 0, 2, 0, 0, 1, negative 1. And you can read off the solution that we got like 5 minutes ago. But, all right, so back to your question, or what I was considering. Take out your calculators. We're going to have to get familiar with our matrix stuff here. So hit the second key, and then right above the X inverse key, you'll see the matrix button. Now here comes an important part. If I want to enter this matrix, I've got to edit the matrix in this dimensions. So, who's my corporate sponsor? RC Cola. Row then column. How many rows, how many columns? 3 by 4. So, go over to edit. Press enter because we're going to edit matrix A. You want to type in a 3 by 4 column. Now, if you have something there, it's just going to adjust things. So for me, it added an extra column. And let's type in that matrix. Is everyone able to get a 3 by 4 matrix there? Emily? You keeping up? hit the second button, then the X inverse key, fourth one down on the left-hand side. It says matrix. Use the right arrow to go to the right. So here, second, go over to edit, and then type in a 3x4 matrix. So once you're there, just start typing in the entries. 1, enter, -3, enter. And when you press enter, it should cursor you through the matrix one element at a time. So does everyone have the matrix entered? Okay. So hit the second key, then the mode key to exit this. We want to get out of this. We're done entering that. If you want to look at it and double check it, you can. Press the second key, then back to the matrix button, and then just press enter twice. First one will put the matrix on your calculator, and then press enter and you see the matrix that you entered. Make sure that you got it correct. But what did I want? I wanted to put it in reduced row echelon form, right? So let's go back to our matrix menu. Hit the second key, then the matrix menu. This time we want to do a little bit of math work on this. So go to the math menu. Go to the right one. Then it's probably easier to go up. If you go up, you'll see two things. You'll see reduced row echelon form, and then above it, row echelon form. Well, let's put ours in reduced row echelon form. So press B, or simply press enter. But reduced row echelon form of what?
You go back to matrix.
Yeah.
Hit A and enter twice.
Yeah, exactly. You got to go back to matrix and type in matrix A. So second, X inverse, type the number 1, or simply press enter twice. And that should give it to you in reduced row echelon form. Nice. And what's nice here is that you can read off the solution, right? 3, 2, -1. There's your solution. Pretty cool.
So could we solve just about any matrix you give us by first putting it into row echelon form and then having the calculator pop into that?
Yeah.
You want us to put it in reverse row echelon form?
You know, you could do so much with these things. I'll tell you this. I've never shown this capability to any of my classes. You're the first. Yay. What's that? Yeah, I'm still going to need to see work. But look, I have no problem with you checking your solutions. I mean, there it is. You can read off your solution right out of this. Okay. I think we're good for today. So let me give you some homework. Section 10.3, 5 through 17, 21 through 25, and I'd practice a few of these, 29 through 35. We didn't get to inconsistent, so we'll leave it off there. We will do some more cool stuff with these things, but there's an exam on Tuesday that'll cover up to and including section 10.3. See ya.
Have a good weekend.
You too. Thank you. Well, I'm still recording.